China has launched an intercontinental missile into the Pacific Ocean again after 44 years. As the National Day approaches, unexpectedly, the rocket force has presented a generous gift for the National Day. At 8:44 on September 25th, the Chinese rocket force successfully launched an intercontinental ballistic missile carrying a training simulation warhead into the relevant high seas of the Pacific Ocean. It accurately landed in the predetermined sea area, and the test achieved the expected purpose satisfactorily. Ordinary people may find it difficult to understand the great significance of this intercontinental missile test. You should know that this is the first time in 44 years since 1980 that China has launched an ultra-long-distance intercontinental missile into the Pacific Ocean again. So here comes the question. Weren't intercontinental missile launches all carried out within the territory in the past? Why is it launched into the Pacific Ocean this time? We all know that intercontinental missiles are one of the most important carriers in a country's nuclear deterrence system and have always been the focus of research and development by various nuclear countries. However, intercontinental missiles have extremely long ranges, often more than 10,000 kilometers. No country has such a vast territory to test intercontinental missiles. Even a country as vast as the Soviet Union felt powerless in the face of the R-36mm to Satan ballistic missile with a range of 16,000 kilometers. So, for a country with a relatively small land area like North Korea, after building an intercontinental missile, how can it test whether it can reach 10,000 kilometers under the condition of limited land area? In fact, there are ways. We all know that intercontinental missiles are a kind of ballistic missile. The reason why they are called ballistic missiles is that except for the acceleration stage, they basically rely on inertial flight in other stages. This process is just like throwing a stone into the distance, so in the case where the throwing range is not enough, we can clearly throw it for 10 meters, but we must throw it within a range of 5 meters. How can we achieve this? There are two methods. The first method is to reduce the force thrown out, that is, thrust adjustment. The second method is to increase the elevation angle, that is, high trajectory ballistic thrust adjustment for ballistic missiles is not as simple as when we throw stones. For liquid missiles, generally, the flow rate of oxidizer and combustion agent entering the combustion chamber is adjusted by turning on and off the fuel valve to achieve thrust adjustment. Solid missiles are more troublesome, because when the rocket fuel column is produced, it has been engraved into different curved inner diameters according to the ballistic requirements. Once ignited, we can only wait for the fuel to burn out. Therefore, it is not feasible to adjust the fuel only by opening the preset opening of the combustion chamber and reducing the pressure in the combustion chamber. Or using a reverse nozzle. Can the thrust be reduced and the range adjustment be achieved then? According to the engine thrust curve data of the missile at various altitudes, it is possible to calculate the maximum range that the missile can achieve if the engine thrust data is not reduced. High trajectory ballistic is not so troublesome. By adjusting the flight direction of the active section and making the missile fly higher and higher, and consume all the fuel in the ascent section, the purpose of reducing the range can be achieved. This is just like mortar firing. After exceeding 45 degrees, the higher the elevation angle, the shorter the range. Similarly, according to data calculation, the actual flight distance of the missile can also be obtained because this scheme is relatively simple. Basically all countries that develop ballistic missiles have used it. For example, the US land-based Minuteman, sea-based Trident, and China's Dongfeng 5 and Jiulang to when China was developing the Dongfeng 5 intercontinental missile. The initial design range was 12,000 kilometers. However, from the east to the west of China, the farthest distance is only 6,500 kilometers. which is not enough for full-range test. Therefore, in the early stage of research and development, the method of launching from the east to the western test range for high-trajectory ballistic tests was adopted. Subsequent series of missile tests are also high-trajectory ballistic. For land-based missiles, they are launched from Taiwan and Jiuquan to hit Lop Nur, or from Xinjiang to the South China Sea. For sea-based missiles, they are launched from the Bohai Sea to near Lop Nur, with a distance of 2,000–3,000 kilometers. North Korea's situation is similar to that of China. In the intercontinental missile test on March 24, 2022, North Korea's Hwasong-17 missile flew 1090 kilometers, but its flight altitude reached 6,248 kilometers generally. The flight altitude of intercontinental missiles is between 200 kilometers and 1,000 kilometers. The advantage of conducting such shortened-range tests is that the organization is simple. After shortening the range, the landing point can be arranged within the territory or in the offshore area, saving neighboring countries from making a fuss. There is no need to arrange particularly complex security measures on the scene. Even if it deviates a little, it is not a big problem. But if a full-range test is to be carried out, then it becomes complicated, because the territory is not enough. It is bound to be launched into the high seas. Advance notifications need to be given to surrounding countries, and fleets need to be dispatched to guard the predetermined landing point to prevent the warhead from being salvaged. In 1980, when China's Dongfeng 5 missile conducted its first full-range test. In order to ensure this test, China assembled a fleet of 18 ships to be responsible for recovering the data cabin. Even so, there were incidents where American and Australian warships attempted to snatch the data cabin. After being blocked by China, the United States, unwillingly, also salvaged a bucket of green seawater stained with dye. Therefore, for some countries with weak naval strength, full-range experiments have a very high risk of leakage. However, although full-range tests are troublesome, they also have many benefits. On the one hand, it can test the long-distance flight performance of the missile and the reliability of its components, especially whether the missile can fly normally and accurately hit the target when it flies out of the measurement and control area. On the other hand, compared to those tests with reduced ranges, full-range tests have sufficient deterrence. So whether it is the United States or the Soviet Union, many full-range tests or quasi-full-range tests have been carried out. For example, for the United States land-based intercontinental missiles, they are generally launched from Nevada in the mainland to the Kwi Atoll test range in the central Pacific Ocean. The straight-line distance is about 9,000 kilometers. For sea-based missiles, most of them are launched from the California Sea area to strike the Kwi Atoll test range. The range is about 7,000 kilometers. Basically, they are quasi-full-range tests. As for the Soviet Union, land-based missiles are generally launched from Pleistsk to strike the Kamchatka Peninsula in the Far East or Baikonur in present-day Kazakhstan. Sea-based missiles are launched from the Barents Sea to strike Kamchatka, although the distance is a bit shorter. Nuclear submarines can move forward and cover the United States mainland without a problem. So here comes the question. What kind of intercontinental missile test is China conducting this time? Is it the legendary Dongfeng 51? In fact, this is probably not a test of a new model. Instead, it is a duty pull. As we all know, both the United States and Russia have several nuclear missile forces on standby 24 hours a day. This is the so-called combat readiness duty to ensure that missiles can be launched immediately upon an order. Taking the United States as an example, the U.S. mainland Air Force is equipped with 450 Minuteman III intercontinental missiles, which are deployed in the corresponding wings of Wyoming, North Dakota, and Montana. Each Minuteman III has its own launch silo and is controlled by several launch control centers. Once these launch centers receive the launch order, all missiles can be launched within 10 minutes. It's similar for sea-based forces. On average, every day, 432 warheads of the U.S. sea-based nuclear force are on duty with a total equivalent of 112 million tons. Coupled with land-based nuclear missiles, the total number of warheads on duty is 873 with a total equivalent of 244 million tons. So, what is the maintenance status of these on-duty missiles? After all, these missiles are several decades old. Is there any dereliction of duty by on-duty personnel? Is the command and communication system unobstructed? In fact, no one is sure. Therefore, both the United States and Russia have an irregular system of duty pull, firing one from time to test the reliability of the strategic missile system in combat readiness. Facts have proved that this duty pull can really detect problems. In September this year, Russia launched a SAR-MED intercontinental ballistic missile from the Plesetsk Cosmodrome in Arkhangelsk Oblast in the north. However, according to media reports, such as Reuters and the New York Times of the United States, the missile malfunctioned and exploded in the silo. Satellite images show that there is a crater about 60 meters wide in the Russian silo, while satellite images of the same location 2 weeks ago did not show this crater. As for China, although there are also combat readiness duty tasks for missile brigades, in order to avoid international speculation, generally, this kind of full-range duty pull is not carried out. Only some high-trajectory short-range test firings are conducted within the territory, hitting targets like aircraft carriers in the desert. However, this time is completely different from the past. Many clues can be seen from the news announcements at 8:44 on September 25th. The rocket force of the Chinese People's Liberation Army successfully launched an intercontinental ballistic missile carrying a training simulation warhead into the relevant high seas of the Pacific Ocean. It accurately landed in the predetermined sea area. This missile launch is a routine arrangement for annual military training and complies with international law and international practice. It is not targeted at any specific country or target. Who is the launching entity? It is the rocket force, not the Aerospace X Institute. Moreover, it is emphasized that it is a routine arrangement for annual military training. This shows that this missile is already a finalized model, not an experimental model. Where is the launch target? The Pacific Ocean. Obviously, this is a full-range test firing. If we measure it on a map, we will find that if it is in the South Pacific Ocean, the range is already close to 12,000 kilometers. In other words, it is closer to a real combat trajectory. What is the payload? It is a simulation warhead, not the data cabin in 1980. Previously, it needed to be recovered. This time, it may not be necessary. More importantly, this time is different from the veiled launch vehicle test in 1980. It actually made it clear that it is an intercontinental missile. I show my cards. I won't pretend anymore. So, why did China suddenly conduct this full-range test firing? The first possibility is very simple, which is nuclear deterrence. Although this launch is routine, after not conducting it for such a long time and suddenly doing it once, it is obviously not simple. At the beginning of 2022, China, Russia, the United States, the United Kingdom, and France, the 5 nuclear weapon states, jointly issued the joint statement on preventing nuclear war and avoiding arms races, emphasizing that nuclear war cannot be won and must not be fought, and pledging that nuclear weapons will not be targeted at each other. However, with the continuous development and changes of the international situation and the flames of war rising everywhere in the world, especially due to the increase in various unstable factors associated with the approaching U.S. presidential election. In order to deter certain adventurism, it is necessary to show one's nuclear capabilities after all. Peace cannot simply be hoped for that the other side will not fire. It must be based on the mutual possession of the ability to destroy now. When China launches an intercontinental missile into the Pacific Ocean, although it claims not to target any country, when neighboring countries see the Chinese intercontinental missile landing at their doorsteps, which one cannot be frightened? The second possible reason is to show the combat readiness level of the Chinese rocket force. We can see that since 2023, 4 of the 5 permanent members of the United Nations Security Council have conducted their respective intercontinental missile test firings. Among them, the United Kingdom's test firing of the Trident II submarine-launched intercontinental ballistic missile ended in failure. Russia's test firing of the Sarmat intercontinental missile resulted in the missile exploding in the silo, also a failure. France's test firing of the M51.3 submarine-launched intercontinental missile was successful. The United States test firing of the Minuteman III missile failed as well because a malfunction occurred in the first stage of active flight, and it deviated from the predetermined trajectory and self-destructed in the air. Now the pressure is on China. Can China succeed? As a result, the rocket force of China dispelled all doubts in society with a perfect test firing. After all, this full-range test firing in a combat readiness state is the highest in terms of both technical level and practicality, fully demonstrating the combat readiness capability of the Chinese rocket force.